Hello everyone! I'm back with another tutorial video based on a case study project using the Go programming language. However, this time I'm doing things a little differently compared to my previous videos. I'll be using AI to help generate content in English. This way, I can share knowledge and explain programming concepts to a broader audience around the world, especially those who benefit from learning through real-world case studies. So, what are we going to learn? We're going to build a simple API project inspired by the Twitter or X application, but in a much simpler form. We'll cover how to set up the project, create database migrations, and build several APIs such as login, register, refresh token, and more. We'll also learn how to join data from different tables and map it properly into API responses. I've tried to organize the folder structure neatly so it's easier for you to understand. We'll use the Golang Gin framework as the foundation and MySQL as the database. Additionally, we'll use several third-party packages like Golang JWT for token handling, Validator for request validation, go.env package to load environment variables from the .env file. And for database migration, we'll use a tool called dbmate. I'm using WSL Ubuntu installed on my Windows system, and I recommend using WSL for this kind of setup. First, I navigate to the code, practice, directory, and create a new folder named Go Tweets. The first step is to initialize the project by running go mod init. Then I create the folders, cmd to store main.go, internal for the main application code, pkg for helper functions and third-party configuration, .env to store environment credentials. Inside the internal folder, I also add config for project configuration, DTO to store request and response structs, handler for routing, middleware for things like authentication, model to represent database entities closely related to the repository layer, repository for database operations, service to hold the main business logic. Finally, I add a Docker Compose file in the root directory to help create and run the database container. You can follow along and use the same configuration. For reference, you can always check Docker Hub. In the Volumes section, make sure to adjust the path to match your local project directory. Since my project is located at Home, eagerdev, Code, Practice, Go Tweets, I'll use that path. Then simply run docker compose upd. And don't forget to turn on the Docker application. It might take a bit longer for you if it's your first time, but for me the process is fast because I've already downloaded the MySQL image before. I use dbeaver as my DBMS. Now let's connect to the database using the credentials found in the Docker Compose file. This is the database schema for the Go Tweets project. We'll also learn how to use join and left join in SQL. In addition, we'll implement soft deletes, where data is not actually removed from the database, but is hidden from the user interface. Next, let's follow the guide on the official DBAmate GitHub. You can install it by choosing the version that fits your operating system. To use it, we first need to create a .env file that contains the database URL property. You can copy and configure it based on the database setup from the Docker Compose file. Now try running the command dbmate. There are many commands available, but we only need new, create, and rollback. Let's start by creating the users table with command dbmate new create user table. This will generate a file inside the DB migrations folder. In that file, you'll see sections marked migrate up and migrate down. To create or alter tables, you write SQL under migrate up, and for rollbacks, use migrate down. Oops, looks like I made a mistake. Let's check the database to confirm if the users table was created. Yes, the users table has been successfully created. You'll also see an additional schema migrations table created automatically by dbmate. This table keeps a history of all your migration files. Now, I'm going to create all the migration files one by one based on the database schema we designed. Next, let's configure the .env file for connecting to the database. Unfortunately, we can't use the database URL format because the connection string format required by the SQL package is different. So instead, we'll define each part of the connection string separately. We'll also set the port and JWT secret in the .env file. Feel free to use your own values, but if you'd like to follow along with mine, that's totally fine too. It looks like there was an issue with the volume configuration in the Docker Compose file. The database volume should not be mixed with the application project directory. So I'll update the volume settings in Docker Compose and then delete the existing volume folder. Next, I'll stop and restart the container using Docker Compose down and Docker Compose up. In my database, there is an error because the DBMS cannot access the GoTweet database storage that we have deleted. Therefore, we need to reconnect. Since I deleted the MySQL volume folder, the database is now empty. I'll rerun the migrations. Now, let's create a config.go file inside the config folder. We'll define a config struct that maps to the .env values. We create each property in the .env file into the config struct. Then we'll create a loadConfig function that returns two values, a pointer to the config struct and an error. Here, we'll use the Godot package and run go mod tidy to automatically install the package. For each property in the config struct, we'll assign the corresponding value from the .env file using go.env package. Let's prepare the main.go file. We'll import the Gin framework using gin.default function. If it's not installed yet, run go mod tidy. Then we'll call the load config function. Now run the application using go run cmd/main.go. And yes, the application runs without any issues. Now, let's create a new folder named internal COL inside the PKG folder. We'll write a connect MySQL function that accepts a config struct as a parameter. Let's check the documentation for GoSQL driver. Install the package as needed. There's a basic connection example we can follow, though I'll make a few custom adjustments. I will create a variable to store the database connection with the aim of making it more dynamic Because I am located in Asia, Jakarta, I will set the database time zone to Asia, Jakarta. And add a log message to know if the database is running well. Next, let's call the connect MySQL function in main.go. If an error occurs, we'll terminate the application immediately. For now, we won't use the DB variable yet since it's not needed. Let's restart the application and see if everything runs properly. Okay, everything is running smoothly, including the database connection. Let's create a very simple API that just returns a plain text response. I'll test it using Postman. Let's hit the endpoint. And yes, the response is displayed successfully. We'll start by building our first API, register. I've already prepared a sample request and response format for this API. The URL will be grouped under the /auth prefix. The request will include 4 properties, and the response will return a 201 status code along with the newly created user ID. Let's begin from the bottom layer, the repository. Inside the repository directory, I created a new folder named user and added a file called repository.go. This file consists of 3 parts, the first being the interface, which aims to define the methods available in the user repository, and the methods we will create later must implement this interface. Then the second one is the struct, which aims to store values that are frequently used in the repository layer. For example, since the repository always communicates with the database, the user repository struct must have a property that stores the database connection. And this property will later always be used by the methods that have been defined in the interface. Then the last one is the factory function. This function is intended to be called in the main.go file, and the invocation of this function will later provide or throw values to each property in the repository struct. In the factory function, I specialize in returning the user repository interface, but within the function, I will return the user repository struct with the aim of abstraction and encapsulation so that the function only depends on the contract present in the interface. Next, in the service layer, I created a new folder user and added a service.go file. The structure is similar to the repository layer. Because the service layer is closely related to the repository, the user service struct needs to add the user repository property. In the handler layer, I also created a user folder and added a handler.go file. Unlike the repository and service layers, we don't define an interface here, since the handler methods will be called directly from the router. In the handler struct, we need 2 properties, gin.engine as the Go framework and user service to call its main method. I also created a method route list which registers the API routes. This method will be called inside main.go. The final step in the setup, we call all the factory functions in main.go. Here, the function is called from the user package. Since in the repository, service, and handler layers, we create another folder named user, it will cause ambiguity or import errors later on. Therefore, I will give an alias for the folder call. For the next preparation, we will create a model first. This model represents the data in the database. Next, on the DTO or data transfer object, in this layer, the goal is to declare a struct that matches the design of the request and response, and in the struct, we add the JSON tag element. Now, let's create a blueprint for the function needed for the registration process at the service layer, and we'll add the function to the user service interface. I will create a function named register, which accepts two parameters, context and request format from the DTO we created earlier, and also return three values, namely int64 for the user ID that's successfully registered, int for the HTTP status code, because later we can set it dynamically, whether the status code is 200, 201, 400, 404, or 500. And the last one is an error, to send the error message to the handler. Then, in the service/user folder, add a new file named register.go. Then we implement the method here. I will provide the logical guide with this line of comments. The first logical process is that we will check whether the user is already registered or not. Next, we hash the password. And finally, we save the data into the database. In this first process, we need to create a function to check whether the user already exists in the database or not. Therefore, in the file repository/user/repository.go, also add the blueprint function in the interface. I will name it getUserByEmail or username with three parameters, context, email, and username, and returns two values, user model and error. Then create a new file named getUserByEmail username.go inside the repository/user folder. Here, I will create the query to retrieve one data from the user table. Then we call the method from rdb query row context, with the first parameter being the context, and the subsequent parameters matching the values that we will send into the question mark placeholders in the query. I created a placeholder variable named result. Then we scan, in this scan parameter adjusting to the column names we call in the query, and it must follow the order. Then we conduct a check. Back to register.go in the service layer, we call the method getUserByEmail or username. If there's an error, we send 0, HTTP status internal server error, and the error. If the data exists or is not nil, then we send 0, an HTTP status of bad request, and a new error message with errors.new. Next, we hash the password with the help of the bcrypt.generateFromPassword package. The final stage, first prepare the variable that will hold the data from the request and the hashed password. Then we also prepare a function in the user repository. Because this is a save process, it requires two parameters, context and the user model. And returns two values, the user ID that was successfully saved and the error. Implement it into a new file named create.user.go in the repository/user folder. Execution with the method r.db.execContext, with the first parameter being the context and the subsequent parameters following the order of the question marks in the query. Then, the way to get the user ID is like this. We call the method in the service layer. Next, we create a function in the handler named register.go. We create the context and request variables from the DTO. We store the value from the request into the variable req using c.shouldbindJSON. And we call the main service, which is h.userservice.register. If there is an error, we will send the error. If there are no errors, we send the status code and the response DTO. In the handler.go file in the route list method, we prepare the URL route. Here I will add the prefix /auth and call the register handler with the post method. Now we test. I am using Postman. We are preparing the registration API. Make the request by adjusting it according to the DTO. The request is successful. Let's check the database to see if the data is saved. And yes, the data has been successfully saved in the users table. However, something is missing. We haven't added validation yet. Here, I am using the Go Playground /validator package. We install in this line, we call the validator. And because the role of this validator is at the handler layer, we add it to each of the handlers. And in the DTO, we add the validate tag to state the rules that apply to each of its properties. Then we call the validation in the handler. If there is an error, we return it with the status code .http.statusBadRequest. Now let's test it again, whether it works. I will try to test the case with the same data, whether there is an error or not. Yes, as expected. Now, let's try to clear the value. Okay, the validation has gone perfectly. Next, we will create the login API. Here is the design. The request only requires an email and password. For the response, we will send two values, the token as the main authentication and the refresh token as the need to obtain the main token if the main token has expired. So, the expiration period for the main token is short, while for the refresh token, we will store it in the database and set its expiration to be longer, lasting for several days. As usual, we create the DTO first for the request and response based on the slide we designed earlier. In the user service interface, we declare the login function. Here, I will return four values. The first string for the main token, the second string for the refresh token, an int for the HTTP status code, and an error if there is an error. Then we create a new file named login.go. We implement the functions that are in the interface. For the flow in this login, the first step is to check if the user is registered or not. Then we generate the token. We take the refresh token from the database if it exists. Then, if there isn't one, we will generate a refresh token and save it to the database. To check if a user is registered or not, we can use the repository method of getUser by email or username. We call here. And we always have to check whether there is an error or not. If there is an error, we just set the string part as an empty string, and we also set it as an error if the user is not found. Then we compare the password in the database with the password sent by the user request using the bcrypt compare hash password function. If the password in the request does not match the password in the database, then we return it as an error. To create a token, I will add a new folder inside the PKG folder. I will name it JWT. Then create a new file named jwt.go. I will create a function createToken that accepts 3 parameters, and the secret key parameter will be taken from the .env file. I am using the package Golang JWT JWT-v5. We can use the newWithClaims function to generate the token, with parameters for the algorithm and the value to be stored along with its expiration. We can run the command go-mod-tidy to automatically install the packages that are needed but not yet installed in our project. Next, I will add a signature to this token, and we return the token in string format and error if there is one. Then in the login service, we call its function. If there is an error, return an empty string, and the HTTP status code. The next step is to create a new function in the repository to retrieve the refresh token from the database. Requires 3 parameters, such as context, user ID for the identifier, and time to ensure that the retrieved refresh token data is a refresh token that has not expired. Because we haven't created the refresh token model yet, let's create it first in the user model.go file. Then the return from this function is a pointer to the model we have created, and the error. Then create a new file for the function implementation. We prepare a query to obtain the refresh token in the database. If the error is an error due to absence, then we simply return nil. Call the function getRefreshToken. Then we check if there are any errors. If the refresh token still exists, then we just return its function, and there's no need to create a new refresh token. If the refresh token is not available, then we need to generate the refresh token. Here, I created a new folder inside the pkg folder named refresh token. The essence of this function is to obtain a random string. Call the function. And because we have generated the refresh token, we need to save it in the database. Add a function to the user repository interface. Let's implement it. Then we call the method. Oops, there's an error here. It seems we have a data type error in the struct. For the expired refresh token, I will set it for the next 7 days. The service is complete next to the handler section. Here, I will copy from what already exists, and we will modify it. We add the URL route with the post method. Let's try a test. Oops, there's an error. It seems there is a problem with the database. And yes, in the refresh token table, we don't have the expired at column yet. We create the migration file. Let's add the alter table query. Now there is a new column, so let's test it again. We tested positive for the case and succeeded. Let's try a negative case. It worked out too. Let's try to test positive again. There's an error again. It seems there is an error in the query. Let's check it. Yes, this is the problem. We are only calling 4 columns, but we are scanning 6 columns. Of course, this will cause an error. Let's try again. Okay, now it has worked. Let's check the database to see if it was successfully saved. And the refresh token is stored. Now we will create the refresh token API. For the concept, first we will check the main token from the header whether the token is truly from a valid user without considering whether the token has expired or not. Then the refresh token received from the request, we will check the database to see if it exists or not, whether the user matches or not, and whether the refresh token has expired or not. If the refresh token has expired, then this API process will stop and the user is required to hit the login API. But if it hasn't expired, the process continues by deleting the old refresh token and creating a new refresh token. Then finally, we will regenerate the main token and return it in the response along with the refresh token. Make the DTO to the request and response design. Add a new function to the user service interface that requires 2 parameters and 4 responses, where the 2 strings are used to send the main token and refresh token. Create a new file named refresh, token.go, then implement the function in the interface. I will provide a hint to help with the process related to the steps. In the user service interface, we need to add a third parameter, which is the user ID. Why don't we just combine the user ID with the DTO? The goal is to create consistency so that the DTO serves as a reference for requests and responses. And the user ID will later be obtained from the token in the header, then processed in the middleware layer. In the user repository interface, we add a function to get the user based on their ID. Then we implement it. And here we create a query to get the user based on the user ID. Next, we call the repository method. And check if there are any errors or not. Next, we can call the existing repository, which is getRefreshToken. Then we always check whether there is an error or not. If the refresh token is not available, then send an error message that the refresh token has expired. We add validation to check whether the refresh token from the request matches the one in the database or not. If they are not the same, we return an error. Then, if they match, we will create a new main token. Add a function in the user repository interface to delete the refresh token based on the user ID. Then implement the function. Call the repository method. We always check for errors. If there are no errors, then we save the new refresh token. The service is complete. Let's add the refresh token handler. I will copy from the login handler to speed things up and modify it accordingly. Then, to get the user ID from the token, we can first prepare the user ID variable by calling c.getInt64 with the user ID parameter, because later Golang Jin will store this value from the middleware process. In the PKG folder, I will create a function for token validation, with the third parameter being whether it has rules or not. Why? Because later, for the API URL that uses authentication middleware, it will certainly need to check the claims validation present in the JWT. But for the API URL refresh token process, we will not check the claims validation. We only need the user ID and the token according to the key in the .env file. To make it neater, I will create a new variable to hold the values from the claims. Next, we create the middleware in the middleware folder. To create middleware in the gin framework, the function must return gin.handlerfunc. I will create two functions, the first for main authentication, the second for authentication specifically for refresh tokens only. We will take the token from the header with the key authorization. Then we trim the space and check. Next, we call the validate token function. If there are no errors, we set the global values such as user ID and username. For the authRefresh token middleware function, we change the last parameter in the validate token function to false. Next in the handler, to use middleware, we need to create a new variable, even though it holds the same route group value. Then use the use function with the middleware parameter we are using. Here we need the secret key from .env, so I will add it to the main.go file. Next, we will conduct testing. Let's try the negative case. And it worked. Now let's try the positive cases. And we receive the new token and refresh token. And the refresh token has also been updated in the database. Let's try with an invalid refresh token. An error message appeared. Now let's try with a valid refresh token, but with a main token that doesn't match and doesn't belong to that refresh token. The testing was successful. Next, we move on to creating the Create Tweet API. For the request, we only need the title and content, and for the response, it only returns the tweet ID. We create the model first, representing the post table that we have created. Next, prepare the DTO based on the previous design, where the request only requires the title and content. The concept is the same as in the user module. For this post module, we also prepare it one by one, starting from the repository, service, and handler, so that I don't have to explain it again. Then we call the function in main.go and create an alias for the import to avoid conflicts. To create the API for creating a post or tweet, we start with the service first. Add a function to the post service interface. In this business process, it's very simple, friends, because it only involves storing data. Then we prepare a function to query and save data into the posts table. Next, we call that method in the create post service. It seems we need to add a third parameter to carry the user ID that we will obtain from the middleware later. Next, create the handler. To speed things up, I will copy from the login handler. Then update a few lines of code for adjustments. Then call the handler method in the route list method. We group the URL within /tweets. Then use the middleware, because for creating tweets, we expect the user to log in first. Next, we test There is a 401 error because we set middleware authentication, so we need to add token header. We copy the token, then paste it in the headers with the key being authorization. Let's try to add one more piece of data. And it worked. We checked the database. Good. The data has been saved in the database. I will try testing with another user account to ensure that the user ID is correct. Yup, we have successfully created the tweet. Next, we create the API to update a tweet. The request and response are the same as for creating a tweet, but we use the PUT method, and there are parameters in the URL. Since the request and response are the same as creating tweets for efficiency, I will update the struct name so it can be used in both the create and update tweet processes. I will rename all the code that still uses the old struct name. Let's test it first to see if there are any errors after we rename the struct. Okay, no problem. Add the update tweet function in the post service interface. We need 4 parameters: context, DTO, post ID, and user ID. First, we will check if the post or tweet is in the database. If it exists, we will update the data. Since we need a query to check whether the tweet data is available or not, we need a query to retrieve a single tweet data based on the ID. We call the method, then we check if there is an error and check if the data is null or not. For the update post method, it seems we only need two return values, the HTTP status code and the error. Because for the response, we can take it from the request obtained from the URL parameter. We also need to ensure whether the user ID matches the one in the database. We prepare a function to query the data update. Then call it in the service. Let's proceed to create the handler. We can just copy the handler from the create post. Then, to get the parameter in the URL, we can use the syntax c.param, but the return type is a string, so we need to convert it to int64 first. Add it to the root list method. Let's test. Add a parameter in Postman with a colon. I will try to update for post ID 1. And I am using the token with the corresponding user. Oops, there's an error. The error is in the query because we are only updating 3 columns: title, content, and updated at. But in the exec context, I included created at, which we don't need. Let's test again. Still an error. Yes, we forgot to pass the value for the post ID, and now it has been successful. I will test for the other data. Okay, the data has been successfully updated. Now, I will test negative with a post ID that does not exist or has been deleted. I will try to update data that does not belong to this token account. Okay, the tweet update is done. Next, we create a delete tweet API. Here we use the delete method by sending parameters in the URL, and for the response, only displays the message. In the post service interface, we first prepare the functions. We'll set the parameters to accept context, post ID, and user ID. Then create a new file with the name deletepost.go. First of all, check if the tweet or post exists. Then if there is, we will do a soft delete. For the process of checking whether tweet data exists or not, we can just copy it. For the soft delete process, we prepare the function in the post repository interface. Then create the soft delete post.go file in the repository/post folder. Because of soft delete, we use a data update query by giving a value to the deleted at column. And now we call the repository method create the handler. I'll just initialize all the values received on the first line of code. We need to parse post ID parameters into the form of an integer 64. Finally, call the delete post handler in the route list method. Let's try the test. Error 401 because we haven't provided the header token. I'm trying to use the token from the refresh token API. Successful. Now check the database. And in the table post, the deleted @ column is no longer null. Okay, next we create an API to like or unlike from tweets or posts. For the design like this, friend, since post-like is still closely related to the post model, we add the post-like model in the post-model.go file only. We create a like or unline post function in the post service interface. We need the post ID and user ID parameters. Then create a new file with the name like or unlike post.go. For the first process, we first check whether the post or tweet exists or not. Then we check the database, whether the user has liked or not. If we have done a like, then we will be different by deleting the data in the database. If you haven't liked it yet, then we set it as a like by saving it to the database. We can use the getPostById repo method. If the post or tweet is nil, we send an error. Next, we need to create a new repo function to check to the post likes table and remove it. Here I will create 3 new functions: isUserAlreadyLikePost, deleteLikePost, and storeLikePost. We implement the functions one by one. Next, implement deleteLikePost. And finally, storeLikePost. First, we call the repo method isUserAlreadyLikePost. If the return is true, then we execute the delete like post method because the user has done a like. If you haven't liked it, then we execute the store like post method. Service is finished, we make the handler. I'll copy from the updatePost.go handler to make it quick. I forgot to do that, but let's do it. Then call the handler in the route list method. It's done, then let's test. Table post, like still empty. We need the token header. I'm going to test for post ID 1. It should fail because post ID 1 has been deleted. Okay, it works. Try post ID 2. Okay, the data is saved successfully. I'll try with other user credentials. Okay, it worked too. Now I'm going to try to unlike, is it deleted? Okie, the data has been deleted. For the post list and post detail API, we will skip them for now because those APIs will require like and comment data later, so let's proceed to the create comment API first. For the design, it looks like this. As usual, we prepare the model that refers to the table in the database. Then prepare the DTO for the request and response needs. Then let's set up the repository, service, and handler first, just like in the post model. We call it in main.go as well. Next, we prepare the create comment function in the comment service interface. Implemented in the file create-comment.go. For the business process, the first step is to check whether the tweet data is available or not. Then, if there is, save the data to the database. Since it already exists in the post repository interface, we can use it for efficiency. However, we need to update the factory function and struct in comment service. In this struct, we call the post repository. And add parameters to its factory function as well. And in the main.go file, we also need to pass it to the parameters. We need to prepare a function to store comment data, so we will prepare it. Call the store comment method in the service. Prepare the handler. I will copy from the create post handler to make it faster. I will add the URL prefix /comment and use middleware. Let's try testing. We need two properties, post ID and content. We need the JWT token. Let's try a negative test first with the deleted post ID. Okay, as expected. Let's try posting ID 2. Oops, there's an error. The error is in the query. The number of values sent does not match. Please add the question mark again. Let's test again. And now it has succeeded. Next, we create the API for liking or unliking comments. The concept is the same as the API for liking or unliking posts. Prepare the model by referring to the database table. Next, to the DTO. Prepare a new function in the service, and we will implement it in the file like or unlike comment.go. The business process is the same as the concept of liking or unliking a post. We prepare functions for the query needs to retrieve comment data. Next, call the method in the service. If there is no comment, then send an error. Next, prepare a function to check whether the user has liked the comment or not in the comment repository. Call the method in the service. Then we also need a function to query deleting likes and comments, and saving likes and comments data. Back to the service, we enter the condition block. If the user has liked the comment, then we execute the delete like comment method. If not, then execute the store like comment method. Let's prepare the handler. I will copy it from the file like or unlike post.go. And finally, call the handler method in route list. I will give it the prefix /action. Last time we tested. Data saved. Let's try to unlike, and the data was also deleted. Okay, now let's move on to the tweet detail API. Here, it will also display the total likes on the tweet along with the comments. We prepare the DTO. Because the response needs to display comment data, we also need to add a new struct to accommodate it, like this. Then create a new struct named comment. In the post service interface, add a new function. First process. We will get the post data based on the ID, whether it exists or not. Next, we get all the comments data that refer to the post ID. Then we map it into the DTO struct. Call the method getPostById, then check whether the data exists or not. Well, since we also need to add the number of tweet likes, we need to update the query because we need to left join with the like post table. And we join with the users table to get the username property. Next, we prepare the repository to retrieve all comments based on the post ID. Then we implement it. We will do validation first, whether the value of the received parameter is empty or not. Next, I will prepare placeholders, as this is needed for queries that use the where-in syntax. Why do I use where-in and not just where? Because later this query can also be used by the API to display all tweet data. For the query, like this, friends, we first store it in a variable because assigning a value to where-in cannot be done directly. To get all the data, we also need to prepare a variable from the comment model in the form of an array. In the comment model, I will add several properties for the needs of this query. Actually, you can create a new struct to make the comment model struct more consistent, but this time I will just add it to this struct because I don't think it's a big deal. As usual, we always check whether there is an error or not. Next, we append to the variable result. Since we prepared the query in comment repo earlier in the factory function post service, we need to add the comment repo property to connect them. Now that we have obtained the tweet data and all the comments data, we need to map it first. Prepare the variable comments map with the data type dto.comment. Then we copy the value by looping through the values from comments to comments map. Why is this done? Because the type of data we need is different from what is obtained from the model query. And the final stage, we prepare the response. Service is complete. Next, we move on to the handler part. We create a new handler. For this tweet list API, I intentionally did not use middleware because non-logged in users can see all the posts. The way is, we need to store a new route group variable without calling the use method. Next, we test. Let's try with post ID 2. Okay, it worked. I moved the parameters to the Params tab in Postman to keep it tidy. Let's also test the tweet data that doesn't have any comments to see if it displays an empty array. And yes, the response has met expectations. Now the final API creation, we create a way to display the entire tweet data. The concept is the same as in the tweet details, but in the response, we will create it in the form of an array. And we will also create pagination. Let's start with the DTO. We arrange the request and response into a struct. I use the param tag to indicate that this is a parameter from the URL. We prepare the function. I will create a file named get all posts.go. Then the steps are, first we need to find out the total number of posts or tweets available. This is intended to perform the necessary query and pagination. Then we query all the post data. Next, we will take all the comment data that corresponds to the ID present in the post data. Then we map all the comment data with the post data based on the same post ID. Finally, we prepare the response by referring to the DTO we created earlier. Prepare a function to get the total number of posts. Create a new file named total post.go. I made the query. Call the total post method from the repo. Because we will be implementing pagination on the response, we need to set the offset value for the query requirements. Then we create a function named getAllPost. And we call the offset in the parameter. Create a new file named get_all_post.go. We will join the users table to get the username, and left join to the post likes table to find out the total likes. Because there is more than one piece of data, we need to loop through it and save it to a new variable. Here, I create a variable named result to hold all the data. In a loop condition, we scan each piece of data into a temporary variable, namely a variable named data. Then we append a value from the data variable to the result variable. Call the method in the service layer. Now we prepare a variable to hold the post ID data in the form of an array. Call the method getCommentsByPosteds by passing the post IDs parameter. Next, we map the comments variable by converting it into a key value format where the key is the post ID. Then we prepare a variable with the data type dto.detailPostResponse. We loop through each post data. If the post ID matches the post ID in the comments map variable, then we take the comment data. We also create a variable for total page. And we arrange the response. Create the handler. The way to get the value of the parameter sent through the URL is with the syntax c.defaultQuery. The method requires two parameters. The first is the key name, and the second is the default value if the query parameter is not sent by the user. Because the data type of that method is a string, we need to convert it to int64 first. Add the route. Let's try a test. Oops, there's an error. Let's try to trace it. The error is here. We incorrectly passed the parameter. Here, we also fix it. The limit of the data displayed by default should be only 5. Now we test. Okay, the data is displayed. I will try to add a comment. Will the comment data appear? And the comments appear. Let's test the page. Okay, it seems to be going well. We have completed the project, a video that is quite long. I hope the knowledge I share can broaden your insights and understanding, and I apologize if there are words that are difficult for you to understand. In the future, I will create another playlist about Golang projects, so just wait for it. Don't forget to like and subscribe so I can be more motivated. Thank you.